We want to look into the vertical motion of an object tied to a string. So let's say an object here is moving vertically like this, and this is the center. It is tied to a string here. Let's do this one. So this is the position where it's the top position, let's say. So the particle here, particle will have different velocities at different points. So at this point, if we call the velocity to be vt, velocity at top position, at this point let's call it velocity at bottom position, and the tension in the string will be towards the center t. So we want to see the velocity at various positions. Basically we want to see the velocity at the bottom and at top, and what is the minimum velocity needed for the particle to make the keep making the circular motion, the vertical circular motion basically. So if we consider the energies at top position, it does have a, if let's say the radius here or the length of the string will be the radius of the circular path. So let's say that's r. So at this point the particle has potential energy and kinetic energy according to its velocity. So the total energy at this point at top position will be mg. M is the mass of the particle or object, whatever, mg times 2r, because we are trying to see what is the maximum potential energy which it has at top position. It is the highest height basically, and this is when the height is 0. When it is at bottom position, it doesn't have any more potential energy. All its energy is converted into kinetic energy. So at top position, this is the potential energy, and the kinetic energy is half mvt square. This one will be converted at bottom position into totally kinetic energy, and the energy will be given by half mvb square. So that's there from energy consideration. And if we talk about tension, when it's at the top position, the tension is towards the center of tension towards the string, for the string towards the center is T, and T plus mg, because we also consider the weight, will be equal to the centripetal force, which is Vt square over R. And when it's in the bottom position, so let's call this Tt, and when it's at the bottom position, that at this position the tension is still upwards towards the center basically, but the weight is downwards, so this will be the centripetal force, mvb square r. Now if we look at this one, the tension has to be at least zero or more than that. So we can say that Tt is greater than equals to 0. If it is 0, it's just rotating, making the motion without the tension, but it has to be like that. So we can say mvt square over r is greater than equals to mg. That is the criteria, because this one has to be, so this one has to be either 0 or positive. So this one will be greater than equals to this one. So we can cancel mass is going away. So Vt square is greater than equals to Rg. So Vt, the minimum value of velocity at the top position, is this one. Now we have this velocity, we want to find what is Vb. We will go back to this equation and we will say it is half m Vb square equals to half m Vt square plus 2mgr. That's what it was. So we can cancel the m's here, we don't need m's. So half Vb square equals to half into Rg square root Rg whole square, so that's Rg, plus 2gr. So Vb square is gr plus 4gr. So Vb is becoming square root of 5gr. We can remember that as well. So this is the minimum velocity at bottom. I have written equals to, but what I should have done is from here it is greater than equals to minimum velocity, because instead of this one I am writing this one, which is this one is just greater than equals to. So from there we get this one and then we get this one. So that's the correct expression, greater than equals to. So that's the minimum velocity when it's in the bottom position, and this is the minimum velocity when it's the top position. Now if we look at the tension here, TB, tension at the bottom. So we want to relate tension at the bottom position and tension between tension at the bottom position and tension at the top position. So TB minus mg is equal to half mvb square. That we know that has to be like that. So half mvb square plus mg. Now what I will do, instead of vb square I can write vt square plus 2g. Instead of h it will be 2r, because that's the height, twice the radius, twice the length of the string. So that one plus mg. So this is becoming half m vt square plus 4gr. There's been a mistake. It should be the centripetal force, not the energy. This one should be, this is not the energy, this is the centripetal force, so that should be r here, and this one will be again r here over r. So this one will be, of course, I will rewrite this one. So because this one is the centripetal force, as is this one, sorry, I wrote kinetic energy by mistake, the expression of kinetic energy. So m over mvt square over r plus 4 mgr over r plus mg. So these are getting cancelled. So this is becoming TV is mvt square over r. What I can do, instead of 4g, I want to write minus mg. Sorry, I want to write minus mg. It was 4 mg, so I have to write plus 5 mg, because this is 4 mg, and then plus mg, which is this mg. So this one is T, tension at top. If we recall this one, tension at top will be mvt square r over r minus mg. That will be the tension at the top position. So this is TT, and then plus 6 mg. So that's the relation between the two tensions. So that's there. This is another relation. So I will do an example in the next video, just and using these equations.